All right. Ultimate Interpretations Guide. Number 1, the way you would interpret that, the heart rate of a student in the physical education class after the mile run, there's your context, typically varies by 7.2 beats per minute from the mean of 105.3 beats per minute. Second one, Juwan's 5K marathon time, or sorry, Juan, not Juwan. Juan's 5K marathon time, there's context, is 1.2 standard deviations above the mean. Interpreting a z-score, all you can say is how far you are from the mean and whether it is above or below. Number 3, if I can get it to go there. There we go. The linear association between number of birds Beast sees and the outdoor temperature is moderate and positive. I would go, honestly, with probably a moderately weak instead of just moderate. I tend to steer clear of the word moderate because it tends to be overused. If you're going to use moderate, say moderately strong or moderately weak. The only thing we can tell from the R value is strength and direction. Number 4, the slope would be the predicted candle height, there's your context, and your Y, decreases by 0.37 inches for each additional hour burned. The Y-intercept, the predicted candle height, when it has been burned for 0 hours, is 9.06 inches. Please don't forget, anytime you are asked to interpret a least squares regression equation, you are talking about predictions. Make sure you get that word predicted in there, or expected would be fine also. Number 5, the actual score on Brian's test was 5.36 points below the number predicted when Brian studied for 3 hours. It would be really important to include this aspect because this is telling you the X value, where the X value was when this prediction was off by that much. On the back side, number 6, about 63.2% of variation in the distance it took the vehicle to stop from 60 miles per hour is explained by the linear relationship with pressure applied to the brake pedal. So R squared tells us how much of the change in Y is because of the linear relationship with X. When we talked about this in class, I told you to think about like your paycheck. Most of the change you see in your paycheck is coming directly from the number of hours worked, but there's that little bit that's taxes that does not directly correlate to the number of hours you worked. So like 99% of the variation that you see in your paycheck is because of the number of hours worked, or is because of the linear relationship with number of hours worked. Number 7, we are 99% confident that the interval from 1.7436 to 2.621 captures the true mean number of transactions per day at this coffee shop. Number 8, a type 1 error. The mean attendance for games last season is actually 2,000, but we find convincing evidence the mean attendance is greater than 2,000. This does not mean that this is the truth. This is what a type 1 error would mean. So if we later find out that we've committed a type 1 error, that's what it would mean. It means the mean attendance is actually 2,000, but we found convincing evidence that it wasn't. Type 2 error, the mean attendance for games last season is actually greater than 2,000, but we don't find convincing evidence that the mean attendance for games last season is greater than 2,000. And then the very last one, assuming the mean attendance for games last season is 2,000, HO is mu equals 2,000. There's a 0.0231 probability of getting a sample mean of 2298.4 or more purely by chance. Because the p-value, 0.0231, is less than 0.05, we do have convincing evidence the mean attendance for games last season is more than 2,000. The HA mu is greater than 2,000. All right. Do you guys have any questions for me on the interpretations page? All right. So next thing I'm going to do is check out calculators to everybody that needs a calculator. And then after that, I am available for questions. I wasn't going to leave anything up at the front for questions because I'm assuming people have very different questions, different places in different packets. So I'll answer those individually. All right.